All right, so we've defined acids and bases, talked about kind of characteristics of both strong acids, strong bases, weak acids, weak bases. Let's talk about titration a little bit more. Okay, so when I take an acid and a base and combine them, I'm usually going to form water. Okay, this is called a neutralization reaction. Just because it's called a neutralization reaction does not mean it has a neutral pH. And so neutralization does not equal, I guess that's a neutral pH or solution. Okay, so neutralization just means I'm taking an acid and a base and combining it. Okay, and so for example, HCl combines with sodium hydroxide, so HCl and NaOH, which is a base, and it's going to form sodium chloride, which is a salt, and water. Okay, so here's my molecular equation. Do you know what this one is? Total ionic equation, and here's my net ionic equation. Okay, so I take two things, combine them. Water is a liquid, we know that, it's a pure substance, and everything is aqueous. Everything else is aqueous, so I can put those as ions in my total ionic equation. Okay, big thing here. So again, you can read this, pause it, and read it. The big idea here is the reaction between an acid and base is a neutralization reaction. Doesn't matter what the pH is. The pH does not have to equal 7 for it to be a neutralization reaction. Okay, so HCl, NaOH form, here's where we're at. Acetic acid, NaOH form, here's where we're at. Okay, fun fact, for those of you going on to Chem 2, you guys will be talking about whether or not it's an acidic salt, a basic salt, or a neutral salt. So, because these are two strong acids, this is a strong acid and a strong base, this is actually a neutral solution. Because this is a strong base and this is a weak acid, this solution and this salt is actually a basic salt. So if you took the pH, it'd be greater than 7. But that's beyond the scope of this class, so we can move on, okay? So as I mentioned earlier, so we've talked about molecular, total, and net ionic equations. Same holds true here. The only difference is instead of dealing with a precipitation reaction, we're dealing with a neutralization or an acid-base reaction. Again, remember, neutralization does not mean it's neutral. It doesn't mean that the pH is neutral. It just means an acid and a base are combining. Okay, so for example, HNO3 combines with calcium hydroxide to give me calcium nitrate and water. This is my molecular equation. I can then take my aqueous things, break them up into ions, leave everything else together so the liquid would stay together. To get my total ionic equation, do you see spectator ions? Yep, calcium, nitrate, those are spectator ions. I could take them out. And here's my neutralization. Here's my net ionic equation, okay? Note, there's no need to put a 2 out there because, again, we always want to write the lowest thing. So even though there's 2 in the total ionic, I can skip that and just write that, okay? So a neutralization reaction does not always mean that the pH is going to be 7. Okay. So of these, so take a break, pause real quick, tell me which the total ionic equation is. Go ahead and name each of them. Are we good? Yes? All right, the total ionic equation is B. This is the net ionic equation, and this is the molecular equation, okay? C. Okay, so again, take a break or pause this and then go ahead and write these out. Write the total ionic and net ionic equations. Are we good? Yes? Okay. This gives you barium chloride and water. Again, it's because it's a neutralization acid-base reaction, it's always going to give you a thing and water. Where are we at? Liquid, aqueous, and 2. Okay, net ionic equation for all these things are going to be the same. It's going to be water plus H plus, oh my gosh, guys, OH minus to give you H2O. Okay. So the net ionic is the same for all of them. I'm not going to write it for all of them. I'll write the molecular equation. Be sure that you're able to write the net, total ionic. And then the net ionic is going to be the same for all of them. Okay. This is water again. And lithium sulfate, which is aqueous. And This is 2. And I think that's, oh no, 2 here too. I think that's it. Please check my balancing, guys, and feel free to send me an email if this is not correct. Aluminum nitrate, also aqueous, and water. Okay, I will have, I think, 6 of this, maybe. 2, 2. Pretty sure. Or not. Hold on, guys. All right, let's talk through this together. Have 3 things of nitrate, so I should have at least 3 on this side. 3 things of OH. All right, guys. I will make sure this is balanced when I go to write it. I feel like I'm stressing out. So I'll make sure it's balanced. I don't want to waste your time on this. But when I go to write this out, it'll be balanced. But make sure to double check that. Okay. Okay, so let's talk real quick about titration. So titration is when I take an acid and a base and I'm trying to figure out the concentration of one of them. Okay, so still acid-base reaction, so neutralization reaction, and it's going to give me a salt and water. I'm able to figure out the number of moles because, again, big idea here is I'm using big M equals moles per liter. I can use that to find moles and determine what the concentration is of either my acid or my base, whichever one I don't know, or volume, depending on what I'm given. Okay, here are some terms that we will use. The titrant is usually, so think about a burette when you titrate, and then the flask. The titrant is usually stuff that's going to be in the burette. I know what it is. I know the number of moles. I know the volume, all of that jazz. The endpoint is going to be the physical point where I can see that the color changes. The indicator is what is going to cause that color to change. And once that color has changed, it indicates that, hey, the endpoint has happened. The substance I'm titrating or trying to figure out what's going on with is going to be in the beaker, and then the equivalence point is going to be when the number of moles of the titrant equals the number of moles of the substance that I'm adding. Okay, so these are terms that we'll throw around a little bit. Here's what a titration would look like. Okay, I take my stuff, add things to it, and then the color changes indicates, hey, I'm going from a different pH to an acidic pH to basic pH, or a basic pH to an acidic pH. Okay, those of you going on to Chem 2, you will do acid-base titrations as well. Big thing here, the equivalence point is where the amount of hydrogen ions equal the amount of hydroxide ions in solution. This is important for when we do our math. Okay, that's what I mean when I say the equivalence point. And the endpoint is kind of sort of the equivalence point, but I can see what's going on there. So it shows that the color's changed. Okay, here's an example. I'll talk you through it, work through it together, and then there are other examples. Make sure that you're able to work through those. I'll have a separate video working through those. Okay, so a 50 milliliter sample of HCl is titrated with that many molar NaOH. Okay, so HCl, so the first step is write out your equation, H2O and NaCl, and this is balanced. It's a 1-to-1 reaction. Okay, the burette reads this at the beginning and then this at the end, which means that I've added the difference. So the amount of NaOH I've added is this minus where it was at initially, which is 33.32 milliliters of NaOH. Okay, so that's how much NaOH I've added. The question asks me to figure out the molarity, so the concentration of HCl. In order to do that, so write my balanced equation, check. Figure out the volume used, check. I need to figure out the moles of NaOH. Okay, so my volume, I need to convert to liters, 0.0332 liters of NaOH. I then need to go from liters to moles. And the way I do that, big M equals moles per liter. And so moles would be big M, which is right here. That's the concentration of NaOH. Times the volume, which I figured out here. Which gives me 5.078 times 10 to the negative third moles, okay, of NaOH. And so now I have the moles of NaOH, but I need to go to moles of HCl. This is why it's important for you to have a balanced equation. In this case, it's a 1-to-1 ratio. So if I wrote this out, I would have 1 mole of NaOH on the bottom and 1 mole of HCl on the top. This cancels out. Moles of HCl is 5.078 times 10 to the negative third moles. Okay. The last part of this is to figure out the concentration or the molarity of HCl. This is what the question is asking me. And so molarity equals moles per liter. So I would take my moles of HCl and divide by the volume. It tells me how much HCl I have. Got to convert that to liters though. And so gives me that, which would be 0.1016 molar of HCl to 4 significant figures, because we're dealing with 4 sig figures out here. Okay. All right. So here's some more questions. Be sure that you're able to work through them. Go ahead and work through them. The next few slides, or the next video I will post, is going to be the worked out version of that. So go ahead and work through by yourself. Be sure that you're able to, and then check the next video out for the worked out problems.